So today we're going to take a look at graphing more linear inequalities, but our focus today is going to be when the linear inequality is written in standard form. You may recall from, I believe it was Unit 1 earlier this year, standard form of an equation is ax plus by equals c. Basically, when x and y are both together on typically the left-hand side of your equation. Now, the only difference today is we're not going to be dealing with equations. We're going to be dealing with inequalities. So you're going to see an inequality symbol instead of an equal sign. So we're going to talk about how to graph the solutions to these linear inequalities in today's lesson. Some of the skills that we're going to use are a continuation of the skills we used yesterday. We still need to figure out where the boundary line goes. So to do that, we have to think about how do we graph equations in standard form. Well, to do that, just find the x-intercept and the y-intercept and graph the correct type of line, whether it's solid or dashed. From there, we just have to decide which side of the boundary line contains all the solutions. And I'll show you a trick for that. All right, so here's the beginning of our notes. This is what I would ask that you write down in your notes. How do I graph a linear inequality written in standard form? Here's the step-by-step approach. All right, so the first thing we want to do is we want to graph that boundary line. All right, because it's an equation or an inequality technically in standard form, we want to find our x-intercept and our y-intercept. As a quick review of how to do that, if you had, I'm just going to use an equation here. Let's say we had 3x minus 2y equals 12. So I had that equation, and I wanted to graph that line that showed all the solutions to the equation. I could take, I'm just going to mark here A, B, and C. I could take those three numbers, and if I want to find the x-intercept, I take C, or 12, and I divide it by the coefficient of x. Again, if I want to find the x-intercept, I do 12 divided by 3. If I want to find the y-intercept, I take 12 divided by negative 2 because that's the number in front of the y. Okay, so my x-intercept is 12 divided by 3, which is 4. And my y-intercept is 12 divided by negative 2, which is negative 6. Okay, so identifying both of the intercepts is your first step, and then we can use those intercepts to graph the boundary line. Make sure that we always check to see which type of line we want to draw, whether it's solid or dashed. We follow the same rules as earlier this week. We draw a solid line if the solutions, or say if the ordered pairs on the line, the boundary line, are solutions. And we draw a dashed line if the ordered pairs on the boundary line are not solutions. So it all goes back to that inequality symbol. If it has the or equal to part of the symbol, you draw a solid line. And if it's not equal to, you draw a dashed boundary line. Once you have your boundary line in place, it is time to shade the solutions. So for this one, it's not as simple as just looking at the inequality symbol and saying, oh, I shade above or I shade below. On this one, we really need to do a test point. I would encourage you to use the ordered pair 0, 0, the origin, because zeros are really easy numbers to work with because you're going to end up multiplying by 0 and adding 0, and it's the easiest number to work with. So what you would want to do is check an ordered pair like 0, 0 and check to see if it's a solution. Keep in mind the shaded side contains all of the solutions. So if 0, 0, or the origin, happens to represent a solution, we shade that side of the line, whatever side has 0, 0. If 0, 0 is not a solution, that means it's a non-solution as well as every other ordered pair on that side of the line. So the solutions would have to be on the opposite side of that line. So we shade the other side. All right. So very similar process for what we did the previous couple of days. We want to graph the boundary line. Make sure you check to see what type of line that you should draw. And we want to shade the half plane that contains all of the solutions. So let's look at a few examples, starting with number 1. We have x plus 2y is greater than or equal to -4. We can see that this inequality is written in standard form because the x and the y are on the left-hand side of the inequality symbol. That's standard form. So to find the x-intercept, I'm going to write my numbers in here first. I want to take -4 divided by the coefficient of x. So -4 divided by 1, well, that's just -4. So I have an x-intercept at -4. So on my graph, I'm going to go ahead and place that right away on the x-axis at -4, right over there. Then I'm going to find my y-intercept, which I'm going to take, again, that constant term divided by the coefficient of y, +2. -4 divided by 2 is -2. I have a y-intercept at -2. So I can see where my line crosses the x-axis and the y-axis, but next I want to determine what type of line to draw before I actually draw the line. My inequality symbol is greater than or equal to. So because it has the or equal to part of the inequality, we're going to want to draw a solid boundary line to show that everything right on the line is also a solution. So I need to draw a line that goes through both the intercepts. It's not too bad. It is a solid line, as we can see there, and it splits our graph into two halves. We have the side above the line that contains the origin, 0, 0, and we also have the side below the line, the half plane below the line, that contains all these points down here. So we want to choose one ordered pair to see if it's a solution, and then that'll help us determine if we graph that side or not. If it's a solution, we graph the side that has a solution. If it's not a solution, we shade the opposite side because that's where all the solutions would be. So let's check the ordered pair 0, 0. To do that, we want to take our original inequality, which said x plus 2y is greater than or equal to -4. Now, if we substitute a 0 in for x and a 0 in for y, watch what happens. 0 plus 2 times 0. Well, let's see. 2 times 0 is 0. And 0 plus 0 is 0. That's why I love working with 0, 0, or the origin, because the math involved is so simple. It just makes everything turn into 0. So we're really just checking to see if this is true or false. Is 0, well, I know it's not equal because they're not the same number, but is 0 greater than -4? Think about your x-axis, your number line. Is 0 greater than -4? Yes, because 0 is to the right of -4. It is a larger value. So the origin, or 0, 0, is a solution. So that means the side that contains 0, 0, the side of the line that has 0, 0 on it, is where all the solutions are. Since the origin is right here, which is above the line this time, we can safely shade all the ordered pairs above my boundary line. All of these points are solutions to this linear inequality that was written in standard form. Anything below the line would have been a non-solution if we were to plug those values for x and y in and check the inequality. So we start with find the x and the y-intercept of the boundary line, draw a solid or a dashed line based on the inequality symbol, and then we check to see where the solutions are by doing a test point. Let's look at another example together. All right, here's number 2. This time we have -4x plus 2y is greater than 4. We're going to start with the same thing. We're going to start with the x-intercept and the y-intercept of the boundary line. So we have, to find our x-intercept, we take the constant term divided by the coefficient of x. So my x-intercept is 4 divided by -4. Well, that's just going to equal -1. Then to find my y-intercept, I'm going to start with that constant term again, This time I divide it by the coefficient of y, which is positive 2. 4 divided by 2 is just 2. So my x-intercept on the x-axis is at negative 1. My y-intercept on the y-axis is at positive 2. Before I draw my line, I have to check my inequality symbol, which will tell me which type of line to draw. My inequality symbol is a greater than but not equal to symbol. Because it's not equal, I'm going to draw a dashed line to show that the ordered pairs on a dashed line are not solutions. So I am going to use the dashed line tool, arrows at the beginning and the end, to draw my boundary line. I may have to adjust this in case I don't get it to go through those points quite right. There we go. That's actually not too bad. Notice how I extended my line all the way above and below the graph, all the way to the outer edges. It splits our graph into two half planes. There's the left side, there's the right side, or you can think of it as the upper left side and the lower right-hand side. Now I can't just look at my inequality symbol and use that to determine if I shade above or below. That doesn't always work when it's in standard form. It only worked when it was in slope-intercept form. So instead, we want to choose a test point that is clearly not on our line. So we can see here that the origin, 0, 0, is not on the line. It's on the lower right-hand side of the line. So let's use that as a test point. We're going to take our inequality, negative 4x plus 2y is greater than 4. We are going to substitute 0 in for x and 0 in for y. And if you remember what happened last time, it's basically going to turn this whole thing into just a 0. Anything times 0 is 0, and 0 plus 0 is 0. We end up with the statement 0 is greater than 4. I want you to think about, is that true or is that false? I hope you recognize that that is false. Saying that 0 is bigger than 4, that doesn't make any sense. Because that inequality right there is false, what that tells me then is that 0, 0 is not a solution, which means then that all of these other ordered pairs on the same side of the boundary line, the lower right-hand side, are also non-solutions or not solutions. So all of the solutions must be on the upper left-hand side of our boundary line. So we are going to shade the upper left-hand side. To show that these are all solutions to that linear inequality. Now, a quick check-in on this one. Because we drew a dashed boundary line, are the ordered pairs on the line solutions? No, they are not. When you have a dashed line, the points right on a dashed line are not solutions. If we were to check any of those ordered pairs that are on the boundary line, what's going to happen is you're just going to get an inequality with the same number on both sides. So in this case, if I use the ordered pair 1, 4, which is clearly right on the boundary line, and if I plug that in, substitute a 1 in for x and a 4 in for y, I get negative 4 plus 8 is greater than 4, and negative 4 plus 8 is 4. So notice I get the same number on both sides. That's going to happen on all of these ordered pairs that are on the boundary line. It's going to give me 4 is greater than 4 every single time when I check that. And can a number be greater than itself? No, it can't. Because my inequality is a strict inequality, meaning it's not equal to, that means that the points right on the line are not going to be solutions. Yes, they represent a boundary, but they don't actually represent solutions in this case. If it was a solid line, then it would. Let's take a look at one more. Last one, number 3. 2x minus y is less than or equal to 4. I would absolutely encourage you to pause the video and try doing this for yourself, and then press play to see how you did if you feel like you're up for it. So we're still going to start with the x and y intercept, trying to find the location of where that boundary line is going to be. And it's always the same way. To find that x-intercept, I'm going to take the constant number, in this case it's 4, and I'm going to divide it by the coefficient of x. 4 divided by 2 is 2. My x-intercept is 2. On my x-axis, I place a dot at 2. To find my y-intercept, I take the constant number 4, I divide it by the coefficient of y, which is -1. Since 4 divided by -1 is -4, my y-intercept is at -4. I plot that on my graph on the y-axis. Now, for the type of line that I need to draw, type of boundary line, I look at my inequality symbol. My inequality symbol has the equal to bar underneath it. That tells me that everything on the line is a solution, so I have to draw a solid line, just a regular old line. So I'm going to draw a solid line that goes through those two ordered pairs. Make sure to extend your line all the way across the graph in both directions. Now I need to try to determine which side of that line contains the solutions. Are all the solutions on the upper left-hand side, or are all the solutions on the lower right-hand side? That's what we need to try to figure out. So we use a test point. And again, I cannot just look at my inequality symbol to determine if I shade above or below. A good test point is that origin, as long as it's not on the line. So 0, 0 is clearly on the upper left-hand side of my boundary line. So that would be a safe ordered pair to check. 2x minus y is less than or equal to 4. That was my inequality. When I substitute in my zeros, I get 2 times 0 minus 0 is less than or equal to 4. And as we've seen now a couple times, this is just going to be 0. 2 times 0 minus 0 is 0. So we're just testing the inequality. Is 0 less than or equal to 4? We would say that is true because 0 is less than 4. So the origin is a solution this time. So that means if the origin is a solution, everything else on the same side of the boundary line as the origin is also a solution. So we shade the side that contains 0, 0, because that's where all of our solutions are. And we just shade it in as best as possible. It doesn't have to be perfect. All right, that is graphing the solutions of linear inequalities when it's written in standard form.